All right, welcome back. Lesson 2 of week 8. The first lesson was all about factoring by GCF. Today we're going to factor a trinomial into two binomials. This may seem a little bit different, but it's not that bad. So just follow along and I think you'll get it. So if we look at the first example here, this is a trinomial, and it has a x squared, or a squared term, and then 13x, which is what we'd call the x term, and then 30, which is called a constant. It's a number that doesn't change, right? It's just 30. And so what we're going to do is we're going to take this trinomial, and we are going to factor it into two binomials. So a binomial is something with two terms in it. All right, and so an example of a binomial would be something like x plus 1, or something like x minus 7. Okay, these are binomials. And so what we're going to do is we're going to find two binomials that we can multiply together to turn into that trinomial. All right, so how are we going to do that? Well, the first thing that we want to notice is that anytime a trinomial starts with x squared, we know that the first term in our binomials will be x, because x times x is x squared. So if we think back as to why this is true, if you remember the box method, got us 4 terms. Remember when we were multiplying binomials, it got us 4 terms, and a lot of times this first one up here was always x squared, and the one in the lower right hand corner was always the last number, right? So we could go ahead and put that 30 in there, right? Okay, so the only way we can make x squared is if we have an x and an x. And remember, the numbers and letters on the outside came from the binomials that we were multiplying together. So all we have to do now is figure out, what number is going to go here, and what number is going to go here. And you'll notice that they have to be numbers that multiply together to equal the number 30. All right, so that's where we're going to focus. We're going to focus on that number 30, and we're going to say, all right, if I have the number 30, kind of like we did with GCF, I know I can do 1 times 30, I can do 2 times 15, I can do 3 times 10, and I can't do 4 times anything, but I can do 5 times 6. Okay, and there's a really simple question that you're going to ask yourself about these 4 pairs of numbers. And the question is, which 2 add to 13? You might be wondering, well, why 13? Well, 13 is this number in the middle here. And if you remember, when we were multiplying binomials, we got that number by adding the 2 diagonal boxes together. All right, and so when we're trying to factor a trinomial, what we're going to do is we're going to look for 2 numbers that multiply to equal 30, but then those same 2 numbers add to equal 13. Okay, and so the simple way to do it is just look at the list and say, well, 1 plus 30 is 31, 2 plus 15 is 17, 3 plus 10 is 13. Well, wait a minute, there it is. 3 times 10, or 3 plus 10, is 13. So I can write this as x plus 3 and x plus 10, and that's it. I'm done. Okay, and now let's do this. Since we have this over here kind of already set up, let's go back and actually put the 3 and the 10 in here and see if it works. Okay, so we've already got the x squared and the 30 in there, and that still works fine. If we look at that upper right hand corner, it's going to be 3 times x, so that's 3x. And then if we look at the lower left hand corner, it's 10 times x, or 10x. And then if we add those two together, we get 13x. So that's what we wanted. Okay, so we were able to find the two binomials that we can multiply together to equal x squared plus 13x plus 30. Okay, so this is a lot of work that I just did, and you know, we can kind of treat it a little bit simpler. We don't necessarily have to do that much work each time. What we can do is just say, all right, I've got x squared plus 22x plus 40. Okay, so I'm going to look at the number 40 and say what numbers multiply to equal 40. So I have 1 times 40, 2 times 20, 3 doesn't work, 4 times 10, 5 times 8, 6 doesn't work, 7 doesn't work. Well, then we're back to 8, so we can stop. All right, and then I'm going to do the same thing here. I'm going to say, all right, now which two add to 22, because that's our middle term. So we're multiplying to equal 40, and then we are adding to equal 22. Okay, so I'm just kind of highlighting the different things that we're doing here. I can even do this. I can say, hey, we're multiplying to equal 40, and we're adding to 22. Okay, and so the answer, we can look at this and say, well, it's 2 and 20, because 2 plus 20 is 22. And so since this trinomial starts with x squared, I know my binomials will both start with x in them. And so I have x plus 2 and x plus 20. And now I could have put the 20 first and the 2 second. It doesn't matter. The order that these are in doesn't matter. You'll get the same result either way. All right, see if you can do these two. Remember, we are multiplying to equal the last number, and we are adding to equal the middle number. Okay, so adding to equal the middle number, multiplying to equal that last number. Okay, so I highlighted them for you, so you should be able to see that there. So do those two, and then when you are done, restart the video, and we'll show you some more that takes it a little one step further. All right, here we go. So if you notice, all 4 of the problems that we've done up above all have plus signs in them. Everything is positive, and that makes things quite a bit easier when everything is positive. What happens when we introduce a minus sign? So here we have x squared plus 9x minus 22. All right, so I might do this a little differently than other teachers do it, but I'm going to do the same thing. I'm going to say, all right, I know that I have to multiply to equal 22, and so I'm going to make that list for 22. I have 1 times 22, 2 times 11, and then there's nothing else that works. All right, and now instead of saying which to add to equal 9, so here we have this problem. If we look, neither one of these pairs of numbers add to 9, right? So if we look at the first one, this one adds to, maybe I don't want to do that. Here, hold on. This one adds to 23. This one adds to 13. Neither one of those are 9. All right. So anytime we have just one minus sign, like we have minus 22 here, we need to think differently. We need to say, all right, instead of which to add to 9, we need to think which two have a difference of 9. Okay, so that means we got to do a little subtracting, right? So difference means subtracting. So if we think 22 minus 1, that's 21. And 11 minus 2, that's 9. All right, so that's what we want. We want this pair right here because they have a difference of 9. Okay, so I'm going to go ahead and erase that thing and say difference of 9. Okay, so now we just have one thing left to do. We have to write our binomials. And this actually can sometimes be the hardest part. And you notice I really quickly wrote them with x's in the beginning because I looked at that and I said, hey, it's x squared. I know it's going to be x's in the beginning. All right, and I know I'm going to have a 2 in one binomial and 11 in the other binomial. And notice how I haven't put any signs in there yet? Well, I haven't because I'm not sure where they go. And I know that if I have a difference, I have to have a positive one and a negative one. Okay, I can't put two positive signs in here because that will end up being 13 when I add those numbers together. I can't put two negative signs in there because that'll end up being negative 13. So one has to be positive and one has to be negative. Well, in this case, since the 9 is positive, that means the 11 has to be positive and the 2 has to be negative. Okay, and let's just double check this one using the box method to multiply binomials, and you'll see what I'm talking about. So we have x minus 2 and x plus 11. Okay, so I'm going to go fairly quickly here. We have x squared minus 2x, we have 11x, and we have minus 22. All right, if we think about that diagonal, we're adding that diagonal. Well, 11 minus 2 is positive 9. So we have positive 9x, and that's what we wanted. All right, so that works. Okay, let's do another one. Here we have x squared minus 7x plus 10. All right, and the thing that's different about this one is now the minus sign comes first, and there's a plus sign with the 10. So we're going to just do the same thing, though. We're going to look at the number 10. 1 times 10, 2 times 5. And in this case, we have a minus sign that's with the 7. So we have to think a little differently with this one. We have to look at it and say, well, wait a minute. If that's a minus sign, that means something has to be negative. When we add things together, they have to be negative in order to add to a negative number, right? But now we're talking about a positive number here on the end. And the only way I can get a positive number by multiplying two numbers together is they either have to both be positive or they're both negative. Okay, so that means that both of the numbers are going to have to be negative. Okay, so if I think about this, I've got a 7 here. I've got two numbers that add to 7, but I need them to be negative 7. So that means I just have to change them to both negative numbers. So negative 2 times negative 5 adds to negative 7. Okay, so I know I have x minus 2 and x minus 5. All right, so that's if we have a minus sign. If the minus sign is with the last term, we're going to have one positive, one negative. If it's with the middle term, they're both going to be negative. All right. Now, one more to consider. What if they're both negative? Well, if they're both negative, that means we have two numbers that multiply to equal a negative number. Well, in order to equal a negative number, one has to be positive and one has to be negative, right? So if we look at 14, we can look at the factors of 14. So we have 1 times 14, 2 times 7. And hopefully you're starting to notice that this 13 is going to show up in this list by either adding the two numbers together or subtracting the numbers. And in this case, it's going to be the difference. We have to subtract, right? So, and if we look at this, 1 and 14 have a difference of 13. And so those are the two numbers that I need to use. And since the 14 is negative, I know one of them is going to have to be negative. So I'm going to have one positive, one negative. And since the 13 is negative, that means the bigger number has to be negative. So the 14 is going to go where the negative is, and the 1 is going to go where the positive is. All right. Here we go, one more. Okay, if we think about this last one here looks very similar to the first one that we did, because it has the minus sign with the 35 and a plus sign with the 2. That means that we're going to have one positive number and one negative number, so we have to look for the difference between the factors instead of adding them together. Okay, so we're going to look at 35. We say, well, 1 times 35. 2 doesn't work. 3 doesn't work. 4 doesn't work. 5 works. 5 times 7. 6 doesn't work. But then we're back to 7. So there's only 2 sets of factors. And we need a difference of 2. So the difference of 2 is going to be 5 and 7. Okay, and remember, one of them has to be positive and one of them has to be negative. So if the 2 is positive, that means the bigger number is positive. So we're going to have x plus 7 and x minus 5. All right, see what you can do. You've got 4 of them to try on your own. Use the 4 that we did up above as examples to help you kind of match them up and say, hey, if both signs are negative, what do I know about my binomials? If one is negative, but if it's the last one, or if it's the middle one. So see if you can figure these out. All right, hopefully you got those figured out. And if you're stuck and need help with the positive negative signs, here's a general template to help you figure it out, to help you organize things. And you can see here we have the first one, we have a trinomial with positive, positive, right? Positive, positive is the easiest one because with positive, positive, everything is positive, right? Okay. The second one, though, if we have the first, or the middle term, I should say, negative, and the last term positive, again, we're going to have the same thing. We're going to have 2 negatives, though, right? Okay, so this is kind of a little template to help you out, and I kind of talked a little bit about this as we were going through, but hopefully this little template will help you stay organized with how to figure these out. And then the bottom is where it gets the trickiest, right? So if we have the last term is negative and the middle term is positive, that means that we're going to have 2 factors, one positive, one negative, but the bigger one will be positive. And then if both of them are negative in our trinomial, one's positive, one's negative, but the bigger one will be negative. Okay, it can take a little bit to get your head around that, but if you're struggling and you need some help, let me know.